Welcome to my channel. In this video, I will be explaining about forging and types of forging. So what is forging? Shaping heated metal by applying sudden blow or steady pressure is called forging. Suppose I have taken one piece of metal and heated it to a particular temperature, and by applying repeated force or sudden blow or continuous pressure, I have deformed the metal in a particular shape. This process is called forging. In this figure, these are the dies. This is lower die and this is upper die, and the red color is a red heated metal. This is fixed die. The lower die is fixed die and the upper die can move upward and downward. It can move the both sides, and after some movement towards bottom, it is shaped. The red heated metal is shaped to like this and after like this. So in this forging process, we can shape any type of metal to any kind of shape. Now let's see this figure. In this figure, the die are slightly different from the upper figure. It is bent in a particular shape. It has particular shape. That shape is created to the desired product. This is called forging. It is done by making use of plastic characteristics of the material. So in forging process, we can't use any kind of metal or any kind of material. The material with plastic characteristics, only with plastic characteristics we can forge them and get a desired shape or get a desired product. Usually the workpiece is compressed between the two dies using impact or gradual pressure to form the part. Forging may be done either hot or cold. So forging can be hot forging or cold forging. So in hot forging, we heated the metal to a particular temperature, and in cold forging, the metal doesn't heated or applied some extent of it. Forging is always stated as hot working unless stated otherwise. So if I say to you forging process, only forging process, it means it is hot forging, and if I say to you cold forging, then it is cold forging. So only forging using means it is hot forging, and if I use hot forging, it is absolutely hot forging. So now we will discuss about types of forging. According to application of heat, the forging is classified as hot forging and cold forging, as discussed earlier. According to use of die, it is open die forging and closed die forging. In two categories it is divided. According to method or use of method, hand forging and machine forging. Let now discuss them. Firstly, hot forging. What is hot forging? Hot forging involves deforming a hot metal which is heated above recrystallization temperature but below the melting point of that metal. So in hot forging, we heated a metal to a particular temperature below the melting point of that metal and above the recrystallization temperature of that metal. Just assume one metal is X, and the melting point of that metal is 1200 degree Celsius and recrystallization temperature of that metal is suppose 800 degree Celsius. So in hot working or hot forging, the metal will be heated below 1200 degree Celsius and above 800 degree Celsius. It can be 900 degree Celsius, 1000 degree Celsius or 1100 degree Celsius. It can be any one, but it must be above 800 degree Celsius and below 1200 degree Celsius. Then it will be hot forging. It is the process carried out between solid and liquid state. So in this particular temperature range, the metal will be in semi-solid state. It will be in semi-solid state. So the force will be very low. We can deform it very easily because it is in semi-solid state. In hot working, the temperature at which the work is completed is most important, since any extra heat after working will aid in brain growth, thus leaving poor mechanical properties. Requires less energy to deform than cold working. Hot metal easily deforms due to plasticity. In hot working, the metal is heated to a particular temperature, so the metal become like heated plastic. So we can easily deform it to a particular shape. Now the next is cold forging. In cold forging, we cool the temperature in a refrigerator and deform it. No, we don't have to cool the metal in refrigerator. It is done in room temperature or in a particular temperature. Deforming a metal to plastic stage at room temperature or below recrystallization temperature is called cold forging. So in cold forging, the metal is deformed in room temperature or below recrystallization temperature of that metal. Again, just assume on metal Y and the recrystallization temperature of that metal is 800 degrees Celsius. Just suppose 800 degrees Celsius. Then the cold working or cold forging must be done in room temperature. The room temperature varies zone to zone, but the recrystallization temperature of that metal will be fixed. In case for Y material, it is 800 degrees Celsius. So cold forging must be done in room temperature or the metal is heated. If needed, the metal is heated below the recrystallization temperature of that metal. In this case, the metal must be heated below 800 degrees Celsius. It can be 600, 500 or 700 degrees Celsius, whatever. The effect of cold forging of steel is to distort or elongate the metal in the direction of applied stress. So in cold forging, this is the product. This is the product and the force is applied in a direction. In that direction, the elongation must be done. Means this is the raw metal and the force is applied in this direction. In this direction, force is applied and the workpiece is going this direction. So the elongation must be in this direction. During the process, grain structure changes and results in fragmentation of grains. Greater loads are required to deform a metal. In cold forging, the force is needed more than hot working because the temperature is lower than the hot forging and sometimes it is done in room temperature, so the load required or the force required is much more greater than the hot forging. It does not get permanently deformed until the stress exceeds the elastic limit. If we take a spring and the spring is elongate to a length and then the force is released, so the spring will get the previous shape of it. But if we elongate the spring beyond the elastic limit of that spring, then the spring will be permanently in that elongate shape. So in cold forging, the metal is deformed until the elastic limit is overcome. So in cold forging, the metal will be permanently deformed if the stress exceeds the elastic limit. So it is cold forging. So in cold forging, the temperature doesn't needed or lower temperature needed, but the force is needed much more than the hot forging. Let's now discuss open die forging. In open die forging, the work piece is compressed between two flat dies, the metal flows without constraint in a lateral dimension relative to the die surfaces. In this figure, the open die forging is shown. This is lower die which is fixed, and this is upper die which can move upward and downward, and this is raw metal which is heated to a particular temperature. If we apply force or pressure to this upper die, then the force will be transferred to this raw metal, and the raw metal will be converted to a particular shape. In this case, the thickness or height of the metal will be decreased, and the circumference area of that metal will be increased. In this case, the product must be in like this shape. Only the thickness will be decreased and the circumference area of that metal will be increased. We can make thin sheet, we can decrease the thickness of the metal in open die forging. We can't make complex shapes, only simple shapes can be made in this process in open die forging. Now closed die forging. What is closed die forging? In closed die forging, the job is forced to fill the cavities or impressions in the dies, thus forming the required shape. So in closed die forging, the word closed means the forging will be in a closed vessel like this. This is lower die and this is upper die, and this is cavity. The red color is cavity which must be blank, and it will be filled with the heated raw metal. This is initial position of the dies. This is lower die and this is upper die. This is fixed and this can move upward and downward. This is heated raw metal. By the help of machine, we can apply pressure with the help of the upper die on the heated raw metal, and after the process is complete, the product will be like this. So the product is inside the closed shape of the dies. That's why this process is called closed die forging. Sometimes excess metal comes out from the cavity as flashes, which is removed by trimming operation. In closed die forging operation, you can see here some blank portion remains. So after the process is completed, the raw metal flashes from this blank like this, and this portion is called flash or flashes. After the operation is completed, we can trim this part from the final product. Complex shapes cannot be forged directly from round or rectangular bar into the die cavity. If we want to forge with round or rectangular bar into the die cavity, we can't do so. If we want to do so, some preforming operation required. That means if we want to make a product from round bar or rectangular bar, then we have to deform that round bar or rectangular bar in a particular shape. After that, that metal is placed here and the operation is done. Number of forging steps is dependent on the shape and size of the forged part. That means if the shape is very complex and the dimension is very long or dimension is very thick or deep, then multiple steps are required. Next, that is hand forging. That means the forging is done by the help of a hammer. The hammer is operated by the hand of a man. Hand forging is a traditional metalworking technique where metal is shaped and formed by the skillful use of hammer and anvil. So in hand forging, we take a heated raw metal and place it on an anvil, and we use a hammer, and by applying repeated force by a hammer, we get desired shape. This is called hand forging. This process has been used for centuries to create a wide range of tools, weapons, and artistic metalwork. Since the modern manufacturing techniques have become more relevant, hand forging remains a valued and respected method for creating unique and high quality metal work. This is hand forging. Now the last is machine forging. So in this process we use machine to create a product. Machine forging, also known as drop forging or impression die forging or press forging, is a manufacturing process where metal is shaped into a desired form using machines and dies. So here this is lower die and this is upper die. The lower die is fixed to it on part of the machine and the upper die is fixed to it on part of machine. That part is called ram, and the lower die is placed on that part is called anvil of the machine, and the blue part is heated raw metal. Now in machine forging we can easily shape a metal to a desired shape. This is the first step, and the final shape is this, or final step is this. The raw metal is converted to this shape, and it can be converted very easily because the force is applied with the help of machine. Usually the machine may be press machine. Unlike hand forging, which relies on manual labor, machine forging involves the use of mechanical presses or hammers to exert force on the metal. Machine forging offers several advantages over hand forging, including higher production rates, consistency in part quality, and the ability to produce complex shapes. It is widely used in the manufacturing of a variety of components, including automotive parts, aerospace components, and industrial equipment. So this is machine forging. So in this video I have discussed about the forging process and the types of forging process. Hope this video was useful for you. For more updates, subscribe this channel. Thank you.